as we continue our conversation on factory hardware reinvented. We've got a double guest episode this week. We've got Chuck and Bill, who we will go ahead and introduce in just a moment. But before we do that, if you guys are new here, welcome. If you've been here before, welcome back. If you're new here and you don't know the format of our show, we will spend the next 60 to 75 minutes having awesome conversations about hardware and especially applications. If you're watching live and you can see some of the really interesting things behind Bill, I think we're all in for a treat today talking about some of those applications. Again, we want to thank Horner for sponsoring this. More about them shortly, and Chuck will give us a very good introduction of Horner in just a minute or two. I would like to say, if you guys are in the Winston-Salem area, Bobby Cole has got a BrewLogix event next Monday, the 21st, going live, and I'm planning to attend. So if you guys are going to be in Winston-Salem, North Carolina, come hang out with me and Bobby, and I think John DeTellum is going to be there. All guests of the show in the past. Come say hi and figure out what goes on with BrewLogix, because Bobby's talked about it enough. I know I'm excited to go see it in person. Without further ado, everyone, welcome to Manufacturing Hub episode 128. We've got two very special guests today, Chuck Ridgway and Bill Reiner. Chuck, Bill, welcome to the show. Thank you guys for being here.
Hey, thanks for having us.
Yeah, thank you. Really nice.
Thank you so much, gentlemen, for taking the time. I think it's going to be a really good conversation from a hardware standpoint. But before we get there, could we get a little bit of an introduction from, let's say, starting with you, Chuck, and then from you, Bill? So tell us a little bit more about your background. How did you get started in manufacturing automation, and then ultimately what it is that you are doing today?
Sure. So my name is Chuck Ridgway. I'm the Automation Technology Manager at Horner Automation. We are a relatively small manufacturer of industrial automation out of Indianapolis, Indiana. I got started, I went to engineering school. I'm an electrical engineer by degree, and I went to a really interesting university. So at my university, it was called Kettering. It's called Kettering University now. It was called something different before, but to get into my engineering school, you not only had to be accepted to the school, but you actually had to have a corporate sponsor. You actually had to have a job before you could even start as a freshman. So basically, you would go to school for a semester, work for a semester, go to school for a semester, work for a semester, do that for 5 years. And then at the end of 5 years, you had a 4-year engineering degree and 2.5 years of work experience. So because that was in Michigan, like a lot of engineers getting started, I was in the automotive industry at the beginning. Started General Motors in a stamping plant, and then I started traveling to automotive plants to work on PLCs. That got me into automation. And then in the early 90s, I moved to Indianapolis and got married and joined Horner Automation. And back in those days, Horner Automation was a third-party developer of PLC products. So back in the 90s, you know, the big guys wouldn't develop all their own hardware. They would have a lot of specialty modules that third-party companies would do for them. And that's what we did at Horner. We primarily worked with GE Fanuc back in the day. And even today, still, we manufacture some modules for the people that own that platform, which is currently Emerson. But really, starting in the late 90s, we kind of turned our attention away from third-party PLC development and onto all-in-one controllers. And for those of you who aren't familiar with all-in-one controllers, if you took a PLC and you add an HMI to that same component and have built-in I/O and networking and all those sorts of good stuff, and that is an all-in-one controller. That's what we call an all-in-one controller. And that's what we've been doing at Horner really since the late 90s. And we're one of the pioneers in that area. Now, for myself at Horner, I started out in applications, because that's where I was in my automation career. I spent a lot of my time in the product management position. And then really for the last few years, I've been kind of a Horner ambassador. So unfortunately, we're kind of the best kept secret in automation, and we're trying to stop that. So I spend most of my time doing online education and online promotion, not just of Horner, but in some industry standard topics as well, some industrial networking and some new products and some integration and those sorts of things. So that's really what I'm up to these days.
Awesome. Appreciate it. Bill?
Yeah, I just started automation recently. I started in 1976 with the Allen Bradley Company. Started out when PLCs were whopping 1K of program space. And it was about the size of a refrigerator. PLCs started out minimum buy-in about $60,000 to give you some idea of what you had back then. Stayed with
Is that
Allen
adjusted for
Bradley.
inflation? Sorry, Bill, or is that the
That
price
is
at the time?
no. Actually, in today's dollars, that would be about $150,000
Wow,
would
okay.
be your minimum buy-in for automation back in the mid 70s. With Allen Bradley, I got a chance to go to several different cities, got transferred to Australia, spent about a year in Australia, spent 4 years in Japan, working in the Japanese machine tool market, which was a very interesting time of my life. Came back to Dallas with Allen Bradley, went to work for an OEM for a short period of time, then went into electrical distribution, high-tech sales. My whole career is automation. I've been everything except for an end user. Stayed in that, got transferred out to California, went to work for GE Supply. Again, high-tech sales, selling GE Fanuc. That's actually in 97 is where I got to know Phil Horner and his group. That's when the OCS was coming out, and I was, selling it. In 2000, I decided that I need to move on, and I opened up a company called OpenApps. It was based around systems integration. I was a Horner integrator at that time, still in today. And we did a couple different products. One was Site Controller. Well, Site Controller grew to the point that OpenApps as a company didn't look right. So I opened up another company called Go Time Controls and renamed it Lights on Sites. So actually lightsonsites.com is a product that we sell to cities, school districts, HOAs, anything to do. And basically you control the lights from your cell phone. And possibly more on that later as we talk about applications. But so that's pretty much my life. I've worked in many, many different applications. I love automation, love talking about automation, obviously. So thank you for having me.
Awesome. Chuck, if I can ask you,
Sure.
I picked up on the point that you made about the program that you had with, working with an employer as you studied. Did you end up staying with that same employer? Did you have different thoughts of looking outside? How did that maybe dynamic influence your decision
Sure.
in joining like manufacturing? And I guess like maybe as a kind of like a forethought for younger engineers who are following the same path, any takeaways on those type of programs versus, just going 3-4 years in college and picking your job at that point?
Well, frankly, the experience is as important, if not more important than the schooling. They're both required, but the experience is critical. So in my case, my corporate sponsor was General Motors, and I worked at a stamping plant in Kalamazoo, Michigan. The plant's not there anymore. And then at the end of the 5 years, they weren't hiring. At least not at that plant. Now, they did give me an offer to go to work in Janesville, Wisconsin at where they made, I believe they were making big trucks or Suburbans or whatever they made back then. But anyway, what I learned, part of the critical part of my experience was this. I learned that I really enjoyed working in plants, but I didn't want to be in the same plant all the time. So I loved working with the guys on the floor, the electricians, the guys that really make the plant run. Even the engineers. Yeah, some of us engineers make plants run as well. But the reality is I didn't want to be in the same plant all the time. So I turned down the opportunity to work in as a maintenance supervisor in the electrical group in Janesville. And I went to work instead for a PLC manufacturer. That was Square D back in the time before they were purchased by Modicon. Yes, Square D had their own PLC back in those days. And I spent my time going in and out of various Ford plants in the Detroit area working on Square D PLCs. So I really, I went from having a little bit of automation background at the plant during my college days to just being thrown in the deep end in the Ford plants as a Square D engineer and for a couple, 3 years, and just really grew my love of automation. And again, what I learned going through college was it's just instrumental in real life lessons of what I wanted to do, what I was interested in. And I learned so much just from that environment.
Yeah, I think those programs are excellent. So I had a slightly different experience. My college didn't necessarily offer like a co-op program. You had to find your own internships during the summer. So I know that depending on where you go to school, it's going to be one or the other. But I think
Sure.
those are certainly excellent, especially that if you can, gain applicable experience, but maybe also get an offer from that same employer, it certainly is a huge plus.
Right.
But I guess like moving into Horner, so you mentioned that at the time it wasn't, their own products. It was more like third party that would like plug in, or I guess like white label. I'm not sure exactly what the dynamic was at that time, but
Sure.
I'm curious again, like what that looked like. I certainly was not in automation,
hmm
in those years. So I'm just
Right.
curious to understand the landscape and how things were managed.
Sure. Sure. So most PLC manufacturers would actually make the high volume components in their system, the back planes, the power supplies, the CPUs, the digital input modules, the digital output modules. But anything that was a little specialized, and in the early 90s, there was a lot that was considered specialized. So like thermocouple input modules or RTD input modules or some sort of communication module. Whether it was an early version of a field bus or whether it was, something like an ASCII basic module where you'd need to interface with a third-party piece of automation through ASCII codes. So all those were considered kind of specialized, and the PLC manufacturers themselves didn't think the volume was high enough to make those. So they would typically partner with another company, and GE partnered with Horner. So we made all those types of modules that I just described. And in the early days of the field buses, when DeviceNet was first invented, and there were those, and Profibus was first invented. Most DeviceNet and Profibus modules that were fitted in PLCs, believe it or not, weren't necessarily manufactured by the major PLC manufacturers. Now, some were, of course. Siemens and Rockwell did the Profibus and the DeviceNet stuff, but like a GE PLC, they weren't sure which one to do, so they had Horner make them both, for instance.
Gotcha. But so would they white label them? Would they still come out as like GE parts but manufactured by you, or were they?
It varied. So it started out, it was always under the Horner name. So that all their distributors would sell the GE product and the Horner product. Just, they would be Horner labeled product from Horner, but sold by the same distribution channel. And then later on, as time advanced, they would prefer to brand label them. So we still make modules for Emerson today, and those are brand labeled Emerson products. Now, we don't make a whole bunch of them. Don't want to oversell that. I think we make 2 or 3 or 4 different SKUs for them. But yeah, we still do it today, but we sell it under their name, or they sell it under their name.
And I'm assuming, I guess, I don't want to take us in a legal direction, but just curious, I guess there's something that protects you from them sort of coming out with their own modules, right? That would replace kind of yours. Is that the deal that you have? Like for, let's say, a certain number of years?
That was an issue back in the early days, but that's why that these PLC manufacturers would have a specific partner that they would partner with. So GE and Horner had a really close relationship, and then Rockwell would have another company that they would work with, and Square D had a development partner they would work with, and Modicon had a development partner they would work with. And so because of, they would establish that close working relationship. And I'm sure in the background with some of them, there were contracts and agreements and all sorts of things. But in general, most PLC manufacturers had a primary third-party developer they worked with.
Really interesting.
Mm-hmm.
Yeah, kind of getting back to the point of analog, and these modules aren't specific. If you think back when I started, there was no analog. It was straight digital control. PLCs were solely a relay replacement device. And I've had plant engineers as late as 1982 tell me that the PLC was just a passing fad. These are full degreed engineers. So it's one of those things. It's just people don't like change, and they find reasons why they don't like something, and that's just my world that I'm used to it, and we started out with 4-bit analog, 8-bit analog. What are we up to now? And how many bits of analog do we have now, Chuck?
Well, it depends, of course.
Yeah.
Could be as many as 20, but 16 is not uncommon.
Yeah. So, but
interesting. I was going to say, I think that's really interesting, Bill. I imagine if that engineer is around, they hopefully now at this point know that 40 years on, the PLC is not a passing fad.
He was 20 years older than I am. I don't know, but he wasn't the only one. I mean, he wasn't the only engineer. And at one point, I've had pneumatic engineers tell me that they were going to replace PLCs. It was very interesting. This was there was a fad for a while to try to do logic with pneumatics.
Really
interesting.
Huh. Well,
Yeah.
I know it's possible, but it certainly doesn't have the same response times, or for that matter, I want to say durability. But interesting.
Yeah, no, there was lots of pushes and subs, and the logic was quote unquote wired because they were doing it. They were using pneumatics as relays.
Interesting. Let me move us forward just a few years from that, Bill. Chuck, you made a really interesting point, right? So your background and Horner's background, building all of these pieces and parts of PLCs. At some point, you guys determined that you needed to go build your own solution.
Right.
How did you get to it? How did you go from building pieces of PLCs to building an all-in-one and deciding that that was going to be the hardware that Horner was going to base itself on for the next generation of solutions?
Sure. So I think it's a fairly interesting story. So one of the advantages of working with GE that we had was, we did I/O modules, we did communications modules, we did HMIs, operator interfaces. About the only thing we didn't do was a logic engine because they had that part of it. But in the mid 90s, the US Post Office had a big automation project going on, and they had specified that they wanted to use a small PLC that was networkable on a conveyor control system, and a conveyor section might have or need 100 PLCs on the same network. And in those days, again, we're not going quite all the way back to the 1980s, but in those days, really only mid-sized PLCs were networkable. The small stuff was pretty much standalone. So all the big guys passed. The major manufacturers said, well, we can supply this mid-sized PLC, but that's all we have. And we're not going to develop something special because even though your volume's pretty good, it's not good enough for us. So GE actually recommended that these government contractors talk to Horner because of the work we had done with them. And we have a very entrepreneurial owner, Phil Horner, who still runs our company today, very entrepreneurial. And because of all the great experience we'd gained with working with GE, the only thing that was lacking was the logic engine, and he wasn't afraid of that. So we literally did design this custom, at the time it was custom, a small PLC with probably 16K of logic capability, full ladder logic. We designed everything from scratch, not only the hardware, but also the software, fully networkable using CAN. And this was just before DeviceNet and CAN Open, and those networks started to become popular. They weren't released yet. They were just specifications. And we were successful. And over the course from about 1995 to about 2000, we sold 35,000 of these networkable PLCs into this huge government project. And it really just kind of gave us all kinds of momentum. The only piece that wasn't included there was no built-in screen. And that was another idea that our owner, Phil Horner, had, where he said, hey, let's take, we spend way too much time as automation engineers, our customers especially, in taking a PLC and having it just communicate with the screen. And we're not even making parts. All we're doing is taking data to and from the screen. That takes up way too much time. What if we embed that screen in that PLC, create an all-in-one controller, and then we'll make sure we have one software package to program everything? Because actually Siemens beat us to the punch a little bit back in those days. They had an all-in-one, but it took 3 software packages to program it. One for the logic, one for the screen, and one for the network. So we didn't want to do that. So we integrated it all. And when he first told me the idea, I said, that sounds dumb. Why do we want to do that? What's wrong with separate components? And there's still some people that think that today, that everything should be separate. But it's been a really successful business for us. There's now probably a dozen or more companies in our product segment making these sort of products. And they're very popular with OEMs, very popular with OEM machine builders.
Absolutely. So in my experience, that's where I've seen the majority of all-in-ones are those OEM machine builders for basically all of the reasons as you've discussed, right? It's one software package Typically, they're replicating the same 1 to 6 pieces of equipment. Sometimes it's slightly bigger, sometimes it's slightly smaller, but basically we can just go ahead and flash the code once onto the new controller and HMI, and we can go ahead and send it out into the field, and we don't have to have a bunch of programmers or other engineers on staff.
Sure.
Yes, absolutely. Vlad, is this going to be the future? Are you just going to write like one all-in-one code to rule them all, and you'll never have to worry about programming another PLC again?
Well, I mean, I think, from that standpoint, I think it definitely is a huge advantage to simplify development for engineers. I certainly spent a lot of time tying in code from an HMI to a PLC and ask myself, like, why is it done that way? I think there's an advantage to making it inside of, I want to say, like one box, but I think more so you've mentioned, the software packages. I think it needs to be like one single experience, regardless, I want to say, of the positioning of the hardware. I think it should still make sense from an engineering standpoint and make it easier to be integrated. So I definitely see an advantage. And I think that, as you've said, for OEMs, it makes complete sense because then it reduces their wiring costs. It makes it easier to put in those panels, and it just simplifies the design in many ways. But I want to ask, to expand a little bit, Chuck and Bill, on that same question of developing hardware, right? And I think that in manufacturing, and again, I play the role of an end user because that's where the majority of my career has been. We always want to have I want to say 30 years lifetime, but at the same time, we also want new updates, right? So we go to a different trade show, we see the new features, and they could be software, which ultimately leads to different hardware. We want it to be adapted and progressive along the way, but at the same time, we want you to be able to maintain that over 30 years. So I'm curious, how do you approach designing maybe like a new product line, but thinking about the architecture that is also going to last all those years and kind of make sense on both ends for the end user, which are, like I said, wanting a product that's similar, but also a product that's always evolving?
Yeah, so that's one of the hardest things that we do because OEMs are our primary product or primary customers. Their products that they sell, they're going to have, they may be selling those machines in that particular design, for several years, 5 to 7 years, let's say, and then they'll do an update to the machine. So, and then they may be, they're going to be doing, replacement parts and all that sort of thing for years after that. So they're really concerned about life cycle. They want the longest life cycle they can get. And yet you still have the pull for new technology, faster, better, all that sort of thing. So how do we handle that? Well, what we try and do is to strike a balance. So first of all, the hardest thing we do is maintain backward and upward compatibility. So the very first controller that we sold, the first all-in-one controller that we sold 25 years ago, the basis of that, the basic core code that it executes, at least the basic code that it executes, hasn't really changed over the past 25 years. So what we've done is we've built and added to that platform. Now, all the electronics is completely different, and the approaches are completely different, and the technology is completely different, but we've maintained building the same code base for 25 years. The reason we've done that is so a company can take one of our products that they built into a machine, 20 years ago, and that core code, they can start with that. So the basic machine logic, they can start with that. Now, all the extra stuff they want to add, all the new technology they want to add, all the updates they want to add in terms of networking and maybe improve performance and building on the logic, doing more advanced things, they have, of course, to add to that core that they may have started with 10 or 20 years ago, but they can start with that. Our biggest goal is to not make our customers start over again, even when they maybe make a jump in 10 or 15 years in terms of product platform. So it's a really tough balance. We try and continuously advance the technology, but keeping the core the same so that customers can make that advancements with us.
Yeah, and from a systems integration standpoint, the Lights on Sights product that's been out since 2000 started with the Horner product, OCS 100, which was released in 1997. I've upgraded a couple times as technology gets better. It didn't, when it first came out, didn't have Ethernet. Then it got Ethernet, and then it got some more things. But I've just migrated without any problems using the Horner product now for over 23 years. And I'm about to go up to a different product, and I don't have to change my base code. Obviously, we do change base code because we add more features to our lighting control system. But I don't lose anything. And if I need to go back to that, I actually do have a few controllers from 2000, I can go back and pick those up and bring those up to current. And that's where Horner does and excels and does just a wonderful job at. And that's coming from a systems integration standpoint. So it allows me to allow my clients to see it seamlessly. It's very good.
And it's a very interesting question, right? And I think that inherently everyone, again, like wants to make it very seamless and sort of as long as possible. But again, on the flip side, I couldn't see how I, let's say, would look into the future and try to predict even all the protocols that might come up, right? So in 5 years, there might be a protocol that replaces Ethernet altogether, right? It might be a completely different medium.
Sure.
Obviously, it's probably going to be still used for a number of years, but ultimately, I always wonder, like, what makes, let's say, a manufacturer say, well, here's a hard cutoff where we're going to go to an entirely different platform, put like whatever we currently have, let's say, on this is going to be end of life product. Here's completely new line. There's a clear separation, and sort of like what brings those like thoughts into play. And again, I'm not saying that Horner is doing that, but I know certainly a lot of manufacturers have drawn that line and migrated to like a completely, I don't know if it's the software limitations, I don't know if it's the hardware limitations, but I'm like always curious because I know hardware is very difficult to develop as well, right? You can't just push an update to all the machines that are in the field and sort of seamlessly patch it up like you would in software. So I'm just curious if you have like the thoughts on that side.
Absolutely. And I totally understand at Horner, because it's so difficult to do what we do. We totally understand when some of our competitors say, okay, enough is enough. We're just going to draw a line in the sand. We have a new platform based on new hardware, totally new software. It's a great product, but you have to start over. So it's totally understandable. And I would say more than likely, the culprit is probably more software and firmware than necessarily hardware. That's more than likely the scenario, is that even though hardware is difficult and it takes time to develop it and to prove it out and get it producing efficiently and inexpensively, the work is really in the firmware and the software. As an example, at Horner, when we do a new platform, where we're not starting over from scratch, but the hardware is very, very new, a completely new core, for instance, of hardware, it's about a 2-year development effort among a lot of engineers to get that new platform, to get the code ported over to the new platform, and then, of course, to add all the extra new technology stuff to that core that were not available in previous generations. So that takes a couple years of time with, I don't know, 40 engineers working on it, let's say, as just a round number. That's a lot of development time. So I can totally understand companies that just draw a line in the sand and said, we're not going to put that effort in.
I find that really interesting, and I think that that's a very compelling story that both you and Bill were telling about kind of the forwards compatibility, and I suppose in theory the backwards compatibility. If anyone like Bill has a 20-plus-year-old controller that he just wants to go throw back out on the line, I think that that's really compelling. Bill, I want to talk a little bit more about the applications, right? So you were telling us before some of these like wild applications that you're doing. Can you share some of that with the listeners? How are you leveraging the Horner products? What are you doing? How did these ideas come? I mean, how did they come to you just in general?
Well, the last question is the easiest question to answer. Is probably a bad way of saying it. I have 2 ears, 1 mouth, and I use them appropriately. If you listen, your client will tell you what you need to do, and all you got to do is do what they ask you to do. The Lights on Sights product started when I had a client that said, I have a lighting control system that's obsolete. They're not listening to me. I want XYZ. I said, cool, I can do that. And that's how the Lights on Sights product was started. So what we've done with lights on sites is we now control several cities' recreational ball fields. And now many people, they can use it to turn the lights on and off. And they put their credit card in there and we charge them and then write the cities back a check. To the point, the city of Rancho Cucamonga currently has 3,000 people in our system playing tennis. I mean, it's just pretty, yeah. There's 3,000 users in there, and they don't get charged a lot. The city only charges like $1 an hour or something like that. But so what our system does is we take it and they will go on the web and put in their information. The web now will transmit that data down to the Horner controller. The Horner controller will disseminate that data, turn on the lights, validate the lights are on, give us back the amount of current coming to the lights, tell us if things aren't working. And then that all can get transmitted back up to the website. Currently, we're using both a REST and Modbus protocol. We will be switching over to the new system. We're probably just going to use Modbus. We're looking real hard, and Horner is coming out now with the MQTT protocol, which is your next thing that's going to be happening. The other thing that we've done with the Horner system that was really pretty cool, anyone that walks through Ontario Airport, all the lights you see on in the parking lot, in the rental area, is controlled by Horner controllers. There's 22 controllers spread throughout both terminals. They're all tied together. They're all using the WebMI product, which is the product you can, go to a web page and see what's happening and reprogram the lights and all that sort of stuff. The interesting thing is where they're coming from. You like this one. Both terminals were controlled over serial interface on an XT computer. One computer was controlling two terminals, all parking lot lights when we started. So that's some of the really, really, really neat stuff we've done. And then some of the other stuff that's more in line with this, this is we've taken the Horner product and we control a pasta cooking line. We controlled 80 motors and we're doing, logging all the data and looking at the average data current coming back from the motors so we can do fault analysis of the motors. We're controlling the mixer. We're controlling the dryers. We're doing all that with the Horner controller. Using their XL Plus, their big guy for that. Other stuff that I've done with it, we're using it in the ice plants. We've used it. It has a big home in pharmaceuticals. We're doing product cycling with it. Product test cycling cells. We put those cells together using the Horner product. And then more building automation stuff we've done with that. And to the point of Horner, the cool thing about Horner is if they see a need for a module, it's not an act of Congress. They made me a module for the building control. And what that module does is, in most cases in the industrial area, we want lights. If something fails, we want it to shut down, right? Well, if you got 3,000 people walking through the terminal, and your control system fails, you don't want all those lights turning off. So what happens is it actually fails on. The IO is intelligent and it says, oh, wait a minute, you're not talking to me. I'm turning everything on because it's more safe to have lights on and let people, talk about that. And then it reports back. Now, I haven't had any failures, but that's the point. That's the difference between the commercial side and the industrial side. Other part about commercial, industrially, we talk about 30 years. We want it to last for 30 years. What the commercial guys are doing, they're selling it until they no longer sell the product and they obsolete it. There was a building built at one of my clients 4 years ago. The lighting system is obsolete. Opportunity for me because I can put an industrial lighting system in there that, by the way, I've been controlling a building at one of my clients since 2000 with the same Horner equipment that's current today. So,
Bill, if I can ask you, so I'm certainly not. Oh, there's a bit of an echo, I think, coming back. Bill, I'm certainly not a building automation expert, but I'm curious, I guess, when you were evaluating the hardware solution, was there like any other advantages that you couldn't use, like a building automation controller? Again, are they too simplistic? Are they not able to be networked? Like, what's the thought when looking at various other options?
To be honest, I'm an industrial guy, and I looked at it from an industrial equation. I wanted something that was going to be around for a long time. And, you know, I talked with people that work for Leviton, and the salesperson came out and said, well, yeah, they sell it until they no longer have a need to sell it, and then they change it. Well, that doesn't fly in our world, in our industrial world. That doesn't fly, but it's put up with in the commercial world. So I'm kind of just bucking the system and saying, saying, okay, that's not the right direction to go. Let's go a different direction with this. And it's working out well. You know, I've got a school district I'm switching over, and they're in the same boat. You know, we're just upgrading their equipment.
But it's an interesting question, right? And I don't know if it's possible to interface those controllers with, you know, the application you've described, where you can probably collect maybe some information in the controller, but I don't know if you could tie it into a server that then would process, you know, payments, send that data back. And again, I'm no expert in building systems, but it sounds like it's not something they would easily handle with
Yeah.
at least like the controllers that I have.
Yeah, no, the lighting control, so the Lights on Sites product is a very customized product. We're the first to market. Okay, there's really nobody out there doing what we're doing. Yes, we have major suppliers that are doing their scheduling systems or their reservation systems. We're a scheduling system where we actually collect the money. That is very specialized. The building that's not really what the building automation really is a step back from that, in the fact that you're just controlling lights, you're controlling density of lights, you're trying to stay with the title now. What is California Title 20, I believe. So you're staying with that. Protocols, when one of the reasons that we got the Ontario project is they demanded BACnet protocol, because their intent is to set up a SCADA system throughout the airport that has BACnet, and Horner had the BACnet there, and it was an easy sell. Now, do they have that SCADA system in place? They do not. But when it's ready for it, it's sitting there whenever they want it.
One other thing, I'll jump in real quick. One other thing that is kind of another factor is that at Horner, yeah, we have our automation group, which we're talking about today, but we also we also are doing business in the industrial lighting space as well. So we have a lighting division, and because of that, we have a good understanding of lighting requirements. And we also, therefore, like Bill mentioned, we're also starting to support and have been supporting, you know, the protocols that are in demand in that space, which primarily these days, you know, is BACnet, MSTP, and BACnet IP. So again, yes, we're an automation company, and they're using, to a certain extent, automation products in a lighting application, but we've also got a lighting division, so we've got a little bit of a hybrid going on there.
I'll have to do a bit of research on BACnet. I certainly am, as I said, not very familiar with the building protocols, but it looks interesting. I posted a note in chat in case anybody else wants to take a glance at the protocol as well. Dave?
Yeah, anyone that's in the facilities control, it's the facilities engineers and managers that really would be the ones.
Yeah, in my experience, that is certainly where I've run into BACnet, is where we're doing building facilities and control. Coming back a bit to the all-in-ones, I had asked the question in the chat if anyone has been using all-in-ones, and Hank has said that they used a couple for some portable equipment that they made some years ago, and it worked well for that application. So thanks for that comment, Hank. Chuck, I guess I'd like to ask you a bit of kind of the next question. I guess I should say, in my experience, every time I've looked at these really, really interesting applications like Bill is sharing the stories of, and I'm feeling super jealous that he's got to go do all of these. I keep looking at the cost, right? And it's if I take, you know, a legacy PLC and a legacy HMI, and I put it in a panel, and I do all of the stuff that I normally do, it's like 5 to 10x the cost of, or sometimes 100 or 200x the cost of what a normal kind of building controls or what would typically be specified. Are you seeing lots of kind of novel and unique applications off of the Horner all-in-ones because I assume they're more cost effective than some of the other larger legacy solutions?
That's certainly, cost is certainly a part of it. It's not the only thing, but it's certainly a part of it. And also you need to kind of look at the total cost of ownership too. And it's not just necessarily hardware cost, right? And which, you know, you may have been referring to. But yeah, I mean, part of the reason we get looked at, you know, for new applications is because people think, hey, if you take two pieces and you put it in one, it must be less expensive. Now, let me say this up front, and that is, you can always buy cheaper, right? You can always find the cheapest stuff available from wherever, and you can always find cheaper. But in general, yes, there's lots of areas of cost savings, especially when you look at the entire equation. Okay, yeah, the hardware generally costs less than the major manufacturers, you know, all the separate pieces. It takes a smaller cabinet very often. Now, of course, for a huge machine, it's not going to impact the cabinet size much. But for a smaller, medium-sized machine, you can shrink the size of your control cabinet. So that's some savings there, obviously. Vlad referred to the fact that there are some savings in engineering time, potentially, when you're doing your development. So it doesn't take as many engineering hours in some cases to do a development. So there's some savings there. And our particular business model also offers some savings. We don't charge for software and we don't charge for support. So there's lots of areas to save money. So that's definitely part of the equation. The other part of the equation, I would say, though, is especially since our target audience is primarily small and medium-sized OEMs, and that is that as a very entrepreneurial automation supplier, we're a little bit more, I guess, engaged with some of our small and medium-sized OEM customers. And we can do some levels of customization, whether that's custom features or maybe a custom overlay, or even in some cases, a little bit of custom electronics inside the case. So, you know, at Horner, because we're so OEM focused, we're very, very focused not only on cost savings, but also on kind of developing that next level relationship with our machine builder type customers.
Yeah. And to that point, I'm sorry, to that point, for the getting back to Ontario, we actually changed out all the controllers on Ontario Airport without disrupting any of the lights, because they were already on latching relays, and we came around behind them, and it's the footprint size of the Horner controller, which allowed us to go in the same space as the old. So we didn't change out the boxes. And what savings to the airport was substantial. I probably left $150,000 on the table on that. That's how much less money I was than the nearest one, because everybody wanted to change out the boxes. So footprint size with the Horner controllers shouldn't be overlooked.
Very interesting. So we have some people to thank, and instead of me doing the ad read, Chuck is actually going to go do the ad read. So I'm going to throw it over to Chuck in the past to tell us more about Horner Automation Group.
Horner Automation is a division of Horner Electric. Horner Electric can trace its roots back to 1949, when George and Mary Horner started their small family-run business, which is now a large, thriving family-run business. Horner Automation has been in operation for over 35 years and is headquartered in Indianapolis, Indiana. Horner designs, builds, and markets a wide array of industrial all-in-one controllers, consisting of programmable control, HMI, I/O, and networking, along with software and peripherals. Many of our automation products are manufactured and assembled in the USA. At Horner, we support our partners, distributors, and customers by providing quarterly factory training on our products and software, as well as an extensive YouTube presence of videos that include software and hardware tips, training, industry solutions, trade show clips, new product releases, and much more. Horner strives to provide value-added solutions for our customers. We have availability, an option for every budget, and incredible support and resources to help your project run smoothly. Everywhere you look, Horner Automation controllers are there.
Awesome. Thank you so much. Thank you so much for doing that, Chuck. It's actually nice to have about 45 seconds worth of vocal break for that. So thank you for doing that, Chuck. Thank you guys to everyone from Horner for sponsoring this theme, the Factory Hardware Reinvented. I will say thank you to Phil Horner. He is in the chat. Thank you for being here to support Phil. And I'd like to mention to the folks on our LinkedIn chat, we are missing some percentage of your comments in here. So if you guys have questions that you are asking and we are not getting to them, we will go ahead and and do our very best to go through the chat as we try to get through that. So thank you to everyone for that. And Chuck, we had talked before the show about something really interesting, and it's the conversation Vlad and I have had a number of times, specifically user configurable IO. And we have talked about it a bunch from the engineering perspective, maybe from the financial perspective of, hey, it would be really interesting if I didn't have to carry a bunch of, IO modules or other things like that. And I know that you said Horner Automation has user configurable IO on your all-in-ones. And I guess I would love to get the Horner perspective on what the value and benefit of that looks like and kind of the feedback from your users, please.
Sure. So one of the things we really try and do at Horner, because we're combining so many components into one in a lot of cases, but this is really just a general design philosophy. It's not specific to our all-in-ones. It also applies to our remote IO products that we make as well and design. Okay. But what we try and do is we try and get the maximum we can in terms of the functionality that's built into the electronics that we design into our products. As an example, so let's say you've got a microprocessor that you're using as part of an IO module for a remote IO module. And that microprocessor, of course, it has the communications that's needed and the basic IO that's needed to run some simple IO or do the communications, as an example, let's say it's a communications bus interface. So the general job of a communications bus interface is to link the communications network, the field bus, whether it's Ethernet IP or whatever, to a backplane of remote IO. Let's give that as an example. Well, typically that bus interface, that's its only job, and that is to, link the field bus network with the IO backplane. Well, when we designed recently an IO block, that IO interface, that bus interface for our new IO system, our design engineers and our R&D managers looked and they said, look at all these resources that are available on the chip that we're using. That's really its job is to do the communications interface. But it also has a 16-bit A to D in there. It's got a couple of 12-bit A to Ds. We're just not using those. Why don't we add a little bit of extra hardware around those resources built into a part we're already using? And let's create some user configurable IO on the bus interface alongside the network interface. So what we're able to do on that particular product is instead of having just the communications interface and no IO on that block, we added 6 user configurable IO points. So a couple of them are configurable as either just a regular digital input with a selectable threshold like 5, 12, or 24 volts. But those same inputs could also be used as a 4 to 20 milliamp input or a 0 to 10 volt input with 12 volt resolution. And then there was a 16-bit A to D channel in there that wasn't going to get used. We had a little more circuitry to that guy. So because of that resolution, now you can do, RTDs and thermocouples and maybe even a strain gauge for the right application in addition to, 4 to 20 milliamps and 0 to 10 volts. So there was another user configurable channel. So really the idea there was, let's take the hardware, let's take full advantage of the hardware that we're designing around, add a little more cost to it, but the value we can give our customers is really high. Because instead of just buying that bus interface with 0 IO when you purchase that one component, now you're getting 6 configurable IO points. And in general, what we've heard from our customers is, hey, I can use that 16-bit analog channel to add that thermocouple that otherwise it would take a completely separate module for. Or I can, I've got this one, 12 volt input or 5 volt input. Now I can use that configurable voltage range instead of doing something special there. So in general, the design strategy, whether it's an all-in-one or an IO base or whatever at Horner, is take full advantage of the hardware that we design in to provide the maximum benefit to customers. That's really what we're shooting for when you're talking about configurable IO.
If I can maybe follow up on that same thought and maybe link it back to an earlier comment on like product management, but also product delivery, which took 2 years, right, to ultimately get back into the market. How do you figure out what is, like very important to the customer versus what might be more of a, I want to say like a shorter lived phenomenon, right? I think there's a lot of talk in our industry, and certainly I want to say outside even more of our industry, about different protocols, industry 4.0, IoT. There's a lot of different components. How do you evaluate and prioritize maybe what you're going to be releasing in the next couple of years, maybe even 5 years?
Sure. Well, for that, I would have to say that what we try and do is we try and stay as close to our customer base as we can. The way we do that is, first of all, we have a very engaged owner. Again, we're not a multi-billion-dollar company. We're a good-sized company, but we're still family-owned, and we have a very engaged owner who loves nothing more than to go talk to customers and stay on top of technology. So Phil Horner does have a lot to do with the directions that we take by keeping his ear to the ground and talking to a lot of customers. And I also have to give credit to our R&D manager and our product manager. Those guys are really paying a lot of attention to the technology and trying to understand how practical is it and what's the actual chance that it's going to get, that it's really going to take a hold in our industry. And because we're relatively small, we will take a few swings at things that the bigger companies aren't ready to take a swing at yet. That gets back to our days as a GE and a PLC third-party provider, where there's a new protocol. Is it going to catch on? Should we do the development? At Horner, we're entrepreneurial and we're a little bit smaller, so we'll take a swing at a few things that we think has a good shot. In some cases, it doesn't catch on, and so we learn what we learn. But in other cases, we've been pretty early on in adopting something that has done really well, so it does pay off a lot of times.
Gotcha. Bill, what are your thoughts? I guess when you evaluate sort of, again, like the hardware that you're buying, how it's going to adapt to the needs of your customers, right? And how do you maybe relay that information back to Chuck or any other manufacturer for that matter when you're requesting or sort of expressing your needs from the customer perspective?
Yeah, the hardest job of an integrator is how do you pick the right equipment? All too often, people will look at it and try and make the application fit the hardware. You have to make the hardware fit the application. And when you run into it where the application can't be met, you just take it back to, well, and Horner's perfect for this, because you take it back to him and says, look, I need this for the building automation. Phil Horner said, okay, and he made me a module. Now, you won't do that for everyone. You got to have a reason to do that, and there's got to be a market. It's just does, but they listen to what your needs are, and the application is what's driving our most of our product guys. They're not out there dreaming, oh, let's make up this new device. Oh, this ought to be great. That's the quickest way of going broke, I know. So you just listen to the market, listen to see how things are going. It doesn't really matter if we're out at the military or if we're out at the ice plant. When you find an application you can't meet the needs of the client, I mean, that's what all of us are around for. Is we got to meet the needs of our clients. So
no, absolutely. I mean, it's a difficult question, right? Because I don't think there's a single answer. It's more of a, how to say, like a fine balance, right? Because I think as a customer, I would want a lot of different features, but I would not always realize what the costs of R&D would be to get that out on the market, right? Because ultimately, I think that a hypothetical, let's say, protocol or something that's being released now might be great on paper, but once like fully developed, may take a lot of effort and dollars at the end of the day. So, but no.
Yeah, I mean it's your swing and the miss that we've we've taken over the years, and we've swung and hit home runs, and there's other modules that Horner came out with that are just fantastic. And what happens is usually you find one client that needs it, and then you release that module, and all of a sudden a lot of people need it. So, I mean, that's kind of the development of the market. And the cool thing about the manufacturers is they're listening to hundreds of OEMs and thousands of end user and collecting data and gathering data. So they're not sitting there living in a vacuum at all. I mean, all sorts of data is coming into them all the time. The guess is going to be, do I make this product, and at the end of the day, will it make me money? And, is there a market for it?
Dave, what are your thoughts?
Absolutely. I think that this is really interesting, and I love kind of the conversation of being a smaller company, being able to go make those choices, right? And being able to try new things, and if there is market for the module, as Bill was saying, being able to go build those modules where other larger companies might not have that opportunity. I think it's also interesting, to Chuck's point, is that it's at least in theory a 2-year development cycle from the, hey, we've built this, let's go figure out how to make sure that we can go take our previous code and make sure that the code base stays the same. I guess, Chuck, you had talked a little bit more about Horner as a whole. You had talked about the lighting. We were focused very much on the automation side. What is there about Horner that we should know beyond what we've talked about so far?
Sure. So we've talked a lot about Horner automation. You know, we specialize in all-in-one controllers. We have a Horner lighting division that specializes in industrial lighting. We do really well with inspection lighting systems. We have some of the best technology out for inspection lighting systems, whether you're talking, you know, automotive or other industries, but mostly automotive. And then one of the challenges in the automation industry is there's never enough engineers, right? And when I'm talking about end user type engineers, not enough guys that can program automation systems. There's a real shortage in the market. We've all talked about it. So we've got a new group at Horner called Horner Solutions, where we're creating some off-the-shelf type solutions that people can purchase. The first one that we've created is a OEE type solution that I've done a lot of promoting on and talking about at various trade shows, which basically is a all-in-one controller pre-programmed in a box as an OEE system that you can bolt on the side of a workstation or a machine, and it'll keep track of all that, you know, machine efficiency and uptime, downtime, good parts, bad parts type stuff. So at Horner Solution, what we're trying to do is we're not trying to replace our system integrators. They're our valued customers and our valued partners. But what we're trying to do is provide some off-the-shelf solutions that'll get customers 95% of the way there. And then for whatever customization that's left, that's where they can engage their local system integrator or one of our partner system integrators to kind of take them the rest of the way there. So that's something else that you may want to know about Horner. We have a Horner Solution, not plural, hornersolution.com area where we highlight some of those solutions.
What kind of, I'm curious on the OE side, what kind of signals do you typically pull in from like machinery, or like what kind of, do you need sensors in addition to what you have, or how do you get that data in?
It's usually just simple stuff. So a couple things. One is you don't have to use a sensor at all. So we have some customers that have manual workstations. People are assembling things manually, and then they'll press the touchscreen, says, yep, I just made a part. But when you do bring in the data automatically, it's usually, you know, a run cycle or a cycle signal or some digital input. It's an output from something else. It's an input to us that basically, you know, causes us to increment our counts. And then there's usually another signal for scrap if you have a scrap situation. But we can also take the data in over an industrial network. So we can take the data in over Modbus TCP or also Ethernet IP if that's what they need in terms of, you know, that signal that tells us to count another part or, you know, scrap another part or whatever the case may be.
Gotcha. Awesome. Dave?
Interesting. I think that's exciting, and I hope that we see more groups helping to build that in to currently existing hardware and other solutions, because I think that will only continue to be more valuable and to make the integrators, the folks in the boots on the ground's life easier and not have to go completely reinvent all of that every single time we go around. But no, I think that is super interesting. I think that this has been a really interesting conversation. As everyone knows, and Chuck, I'm going to tee you up first, that I always like to ask people, it's one of my most fun questions, is what the future of automation and what the future of perhaps all-in-ones look like. And I feel like we should have gotten Phil Horner on, and we could have like gone and played his video of what it is. Alas, the next time we have Chuck, or perhaps we get Phil on, we will have to go ask Phil that question. But Chuck, what do you imagine that the future of automation and these all-in-one solutions are going to look like in the next handful of years?
Well, I think one of the things that is definitely going to catch on, it's going to take some time because everything does in the industrial world. We don't take any technology that's totally unproven and apply it right away. But I think the next big thing, and I'm hearing this from our R&D manager, and I'm hearing this from Phil Horner, really machine, and of course customers, machine learning is the next big thing, or one of the next big things. So you can imagine whether you're talking preventive maintenance for vibration monitoring or maybe motor monitoring, or you're talking about process control where you've got some tricky process control and how machine learning could, learning about the process, learning how to optimize the process, how that could really thrive in our environment. So I think machine learning is something that's absolutely going to happen. One of the questions is going to be, is that machine learning going to be, what level is that going to be done at? Is it going to be done at the machine level? Is it going to be done in the cloud? Is it going to be done somewhere in between? So there's a lot of questions to be answered there. But at Horner, we're putting some R&D dollars behind trying to answer that question and seeing where maybe we can fit with some of our highly integrated products in the machine learning space.
I'm curious if you have any like specific use cases that you're maybe driving towards, or you're just in general like exploring giving the tool of machine learning to maybe like end users or OEMs.
Well, I think one of the areas that we're starting in from an R&D standpoint is, I believe, in motor monitoring. Monitoring, I believe it's current and maybe even vibration to a certain extent on motors to try and predict, and to try and kind of predict failures or recognize failures and those sorts of things. I think that's one of the early R&D areas we're involved in. And one of the reasons it is because our parent company, Horner Electric, is one of the largest industrial motor repair shops and all service suppliers in the country. So we've got some expertise in other parts of our corporation there. And I think that's one of the areas where we're saying, hey, would be a good place for us to start, just because of our, in-house expertise, if you will.
Oh, that's really good. Plus, as you said, it's a quick value add, right, for existing customers that are already using your solutions. It's really good.
Interesting. No, I would agree. I think it's very interesting. I think that it will be interesting to see if we end up doing machine learning at the controller or at the edge level versus if we do it in the cloud. And I think that is certainly something that probably will not be decided in the next 2 to 5 years. I imagine we'll see a bunch of solutions at all of those levels, and we'll have many more conversations surrounding that. So thank you for that, Chuck. Bill, I want to ask you a similar question. Where do you see kind of this industrial hardware being used? Do you see it being used in a lot more of kind of these novel non-industrial applications like you're seeing? Where do you predict that that's going to go in the next handful of years?
Yeah, I think it's going to be boiled down to where it won't be commercial industrial. I mean, you got equipment that's being made and the costing of it. I mean, the big thing you're going to see change probably is IO buffering is going to change substantially with IO Link. Those products, you're seeing major manufacturers, Schneider and Eaton, coming out with their systems where they're using CAN interfaces all the way down to the limit switch contactors, starters, all that sort of stuff being pulled back into the controller. So you're going to see IO buffering change substantially in Horner's in there with the IO Link product interface that they have. So there's the building automation requires something a bit different. So I don't know how much of the industrial stuff will be crossed over. I think that the way you talk to it will cross over. But, you got, light sensors aren't necessarily required on the manufacturing floor, so that would be my thing, is that from a control standpoint, absolutely. If somebody wants to build, and I know some other larger firms that are doing building automation and they're using PLCs for it. I mean, it's there now. It's a better solution because we don't obsolete thing every 3 years. Otherwise, we wouldn't be in business.
Absolutely. No, I would agree with that. I think that those are very interesting. I think that those are very interesting potentials. Chuck, I'd like to come to you. You know that we like to ask for book recommendations. Can I ask you for a book recommendation? Put you on the hot seat, please.
Sure. So my mom was a reading teacher. She taught thousands of people to read, including me, which was good. I love to read. Usually I'm reading for enjoyment. She loved Agatha Christie, so detective fiction is still what I read. So for enjoyment, it's usually John Sanford, Lee Child, Michael Connelly, that sort of thing. But let's talk about something a little more important than just reading for enjoyment. So a lot of us have careers we love. We work really hard. It puts a big strain on our family life. So my recommendation is going to be Dr. Kevin Leman. Okay. Dr. Kevin Leman is a terrific common sense author who's written tons of books about marriage and tons of books about raising kids. So before we can be successful in our professional career, we need to make sure things are great at home. So my recommendation is Dr. Kevin Leman. The best scenario for all of us that are lucky enough to be married is to get with our wives, get with other couples that are friends of ours, get a Dr. Leman, one of Dr. Leman's marriage studies, and spend a few weeks, one night a week, learning about that and make sure everything's good at home, because if things are great at home, then your professional life will be unlimited.
I love that, Chuck. I think that is amazing. And I think it very much dovetails into the next question of some career advice. So I will preclude the make sure everything is kind of is good at home. But what is your kind of best advice for early to mid-career engineers, folks in this industry or looking to get into this industry, please?
Sure. So for me, for anybody who's looking to get into the industry, get some experience, however you can do it, right? If you're young in your career, you don't have a lot of responsibilities yet. Maybe you're still going to school. Maybe you're not even going to school. But if you're interested in automation or something in the industry, do some research, find some companies that are doing things that you're interested in and just trying to get in there, whether it's an internship or whether it's just a lower level, entry level job. And take a look at some smaller companies, because one thing that could happen for you is if you can get in with a smaller company that's doing things you're interested in, it's very possible you'll get some meaningful work really early on that you would maybe never have that type of opportunity with a larger company. There's lots of great larger companies. I'm not saying avoid them. I'm just saying at a small company, there's some potential advantages there. So for early folks that are looking to get started in the industry, that would be my recommendation. And then for those of us, well, I'm a little later in my career, but for those in the mid-career, just make sure you love what you do what you love. Because at this stage in your career, of course, we're all going to have bad days. We all have to feed our families, but job enjoyment should be number one on our list when we're middle through our career. We better be liking what we're doing. And that's my advice.
I think that is great advice. I'm not sure we've ever had job enjoyment being number one mid-career, but I think that is good advice for just about anyone. So thank you for that, Chuck. Bill, I would like to come over to you, and I think that you've got a slightly different perspective of kind of career advice. So if someone were to come to you early to middle career asking for some career advice, what would be your advice for them?
Well, I mean, it dovetails into what Chuck was saying, and I can't overemphasize, my life would be a living hell if I didn't love automation. Okay, by the time that you reach mid-career, you should be able to find what you like, and I would say pursue that. And don't worry about the company that you're going to work for. Look for something that you like to do. If you're talking about someone that's just starting out, I would say go to work for a small company. Because a small company, you're going to wear more than one hat. I can guarantee it. You're going to do a lot of different stuff, and you'll find stuff you like and stuff you don't like. Always work for a good company. You don't have to put up with any company that puts you under their thumb. It just doesn't work. You're going to hate the career. You're going to hate the path. You may even change and do something different when you're very good at it, but you're working for not a really good company. So my point is when someone comes to me, and because in my business, nobody really teaches people integration. Okay. Yes, they know PLCs. Yes, they know motors. Yes, they know drives, but do they know how to put them all together? Usually not. So for me, it's a long training cycle. It's an 18-month training cycle for pretty much anyone that's coming to me. And I'm fine with doing that if you're a good person, if you're willing to learn. So be willing to learn and say yes. If you don't know, just say yes. You can always change it later. But if you go in saying no, you've closed doors. You know, that literally led me around the world with Alan Bradley. You know, seriously.
I think that is some great advice. Thank you for that, Bill. I want to come back to you and ask you the last question is thank you so much for being here. how can our listeners help you? Who should reach out? Are you looking to hire? Are you looking for new clients? Are you looking for new interesting lighting and control application ideas? How can our listeners help you, Bill?
Well, I mean, we're always looking for business. I'm a little bit ADD. I like doing a lot of different stuff, and I tend to do more things than I should. But if you have an automation need, then look me up. We're in California, and this is pretty amazing. I'm in California, and Chuck's in Indianapolis, and it sounds like you're on the East Coast. And Vlad, are you on the East Coast as well? I'm not sure.
I am.
So we can, in this day and age, this is fantastic when you can sit and have a conversation across the country. But no, if you have, it's more, to me, it's never what a client can do for me. It's what can I do for my clients? If you have an automation need, and an automation need is, do you know Monday morning if that machine's actually going to turn on for you? And if your answer is, I don't know, you have an automation need. It just really is true. It's amazing. The LA Basin is full of that. You got companies that don't know that their equipment's going to start up in the morning. So that's how I can help them, and by helping them, I help myself. And I never look at it as what they can do for me. I always look at it as what can I do for my clients. So it doesn't matter
absolutely.
if you're control or industrial. It doesn't really matter.
No, I think that is fantastic. Thank you. Thank you for that, Bill. Chuck, I'd like to come ask the same question. Again, thank you so much for being here. We will continue to certainly talk about Horner, and I know that I've got a number of things that I need to go take a look at after the show, and Vlad always does. But how can we help you guys? How can our listeners help you guys? Again, kind of same questions. Are you guys looking to hire? What type of new clients are you looking for? We should make sure that we promote the stream, because I know that you also do streams, I think, just about every week. So please, kind of, you're open for them.
Okay, very good. So really, if you're an automation user and you're curious about this concept of all-in-one controllers, and maybe that's an alternative you haven't looked at, take a look at us. Go to our website, www.hornerautomation.com. You'll get lots of good information there. We do have a YouTube channel with hundreds of videos that we've done, not only teaching people about our products and how to use them, but also with just kind of industry general type topics. If you want to learn about IO-Link, or you want to learn about Modbus TCP or Ethernet IP, or how PID tuning works, that sort of thing, we have some general education as well. So it's not just to sell the Horner products. I'd suggest that you check that out, our webpage and also our YouTube channel. If you'd like to talk to us in person, that's one of the things about my job I love to do the most. We've got some trade shows coming up. In October, we have WEFTech. Got my cheat sheet here. WEFTech, which is the Water Industry Show, October 2nd through the 4th in Chicago at McCormick's Place. And then Process Expo, also in Chicago, October 23rd through the 25th. Also, again, at McCormick's Place. And then we're going to be at the AHTD conference. They're having a tech showcase on the 26th of October. That's down in Marco Island, Florida. Darn, I'm going to have to go down there and see folks in Marco Island, Florida. It's tough, but somebody's got to do it. So I'd love to see folks down there as well.
No, that is awesome. Thank you so much, Chuck, Bill. Thank you guys so much for being here. Thank you for Horner Automation for sponsoring this show and the entirety of the Factory Hardware Reinvented theme. If you guys missed last week, we had an awesome conversation with David Nichols. We've got 2 more conversations coming on. So if you guys are watching on LinkedIn and you haven't connected with Bill or Chuck, please absolutely make sure you go ahead and do that and follow Horner Automation and Solutions Group. It should all be linked on the LinkedIn there. And then as you guys are doing that, please make sure that you're following Vlad and myself and Manufacturing Hub. We have live conversations every Wednesday at 4 o'clock. We've got podcasts of those conversations that come out on Thursdays. And if you guys have made it this far, please remember to hit that like. Please subscribe to whichever YouTube or LinkedIn channel you guys are currently watching. I see that we've got a bunch of folks on the Horner Automation channel, so thank you guys for joining us here. That has been awesome. And if you're listening in podcast form, please rate us 5 stars. Please remember to do all of those like, share, and subscribe things, because I have found that if I remember to ask you guys, our numbers continue to climb, which is just, one of those strange coincidences and why we have to do it every week. But until next time, we'll see everyone soon. Thank you. Bye-bye.